If it doesn't actually solve a real problem that a real human is willing to part money with in order to have that problem solved for them, it doesn't matter how sophisticated it is, or actually it doesn't matter how much data you have if it's not solving the right problem.
You're listening to Gradient Dissent, a show where we learn about making machine learning models work in the real world. I'm your host, Lucas Bewald. Today I'm talking to Angela Bassa and Danielle Dean. Angela is an expert in building and leading data teams, and she's the director of data science at iRobot. Danielle is the technical director of machine learning at iRobot, previously at Microsoft, and has a PhD in quantitative psychology from UNC. All right, so Danielle and Angela, so you are both super technical, but also managers and leaders of teams. So thought we might start out with kind of your thoughts on how you've approached building a technical team, how you got started, and kind of what you've learned as you've built teams.
Yeah, it's really nice to be here talking with you guys.
Yeah.
So at iRobot, we've had sort of an interesting evolution of how we approach machine learning within the organization, and it's really quite significant to have this partnership because Danielle is just amazing, and I really, really, really love working with her. And so the two of us have a really good complementary style. So my background is a little bit more towards theoretical and applied math. And I sort of grew up in modeling of systems. So modeling soybean trait introgression in agricultural settings, modeling epidemiology processes within certain geographies or disease spaces. So all of that is very distant from robotics, but it turns out that a lot of the tooling, and not to bring agriculture again, but there's a lot of cross-pollination that's been really useful. But Danielle also has a really different background that I'll let her talk to, which sort of gives robustness to how we approach these problems.
Yeah, super excited to be here today. And yeah, thanks, Angela, for the introduction. It's been great working at iRobot and thinking about building the machine learning organization. I think one thing that's been really great is thinking about how do we bring different perspectives and different people into the skill set. So people from computer science background, people from statistics background, people from geology and biology and chemistry, and people have really different experiences. And so thinking about building a team that can solve real world problems for our customers is really exciting.
So like, for example, when you two work together, can you think of a time that you sort of brought different approaches to a problem? Or, I mean, how would you kind of explain the difference between the way you think through things?
I just grew up working in investment banking and strategy consulting, and then marketing organizations. So my background is a little bit unorthodox, but sort of very real world oriented, which is sort of the part that has been helpful. And one anecdote that I like to sort of highlight to this end isn't my personal one, is another leader on our team, Teresa Borkovich, who manages the data science team, and she has a marine biology background. And so when we have been thinking about how is it that we analyze data that's coming from teaming missions. So we have robots that can work in tandem, and there's the mopping robot and the vacuum robot. So you can have the robot vacuum your room and then go to a different place, and then the mop comes back afterwards and completes the mission. And so she had a really interesting way of thinking about that problem because she had done a lot of research with pods of dolphin. And so she's looking at the artifacts of that system, because dolphin can't tell you what their intent was. They can't tell you what they were trying to do, but they are acting, and through sensors and data collection, you can sort of get the artifacts of that and then do analysis to try to derive deeper insights. And she was able to bring all of that knowledge. So that literature exists, right? That knowledge exists, and she just was able to think about it differently and really enrich the way that our team dealt with that. So we do have sort of a bias towards real world experience and ways in which we understand that we're looking at fossils. And so when we project what the dinosaur looks like, our dinosaurs tend to not have cartilage and feathers because we wouldn't have known that just from the fossils. But we know that the real world is richer than what we're looking at. And I think that allows us to build sort of more solid answers to how we use these ML applications.
Interesting. Do you have anything to add?
That was such a good story. I can't add to that.
It's funny. I mean, just as an aside, I remember I had the first machine learning team I worked on. My boss, Jean-Marc, he always said that he liked to hire biologists because they look at the specific examples versus he actually was a physicist, and he's like, I hate hiring other physicists because they always try to like kind of look in generalities instead of the specific. And he felt like what the team really needed was more people to kind of just look at the actual training data and like the specific things that were feeding into the model. So it's funny, I haven't thought about that in 15 years maybe, but he was always talking about that. So
yeah, and it's huge in our domain because we have these robots deployed literally in every time zone globally, all across the world. And, I've never lived in every place in the world. So we will look at data, we will see information, and I will construct a mental model of what might be happening. But if we don't have a team that's sort of robust and can challenge a lot of our heuristics and baked in assumptions and go, I don't think that means what we think it means. And it forces exactly what you're talking about, descending into the particulars and really examining what is it that the data's telling us, not what we hope it aligns with, because we have this sort of perfect first principles model of what it should be.
iRobot has been around for a long time building robots. And I think robotics, traditionally, didn't do a lot of machine learning. I mean, always, I think there's always obviously relevant, but it wasn't kind of machine learning first until, maybe recently. I'm kind of curious, like the evolution of, if you know it, of iRobot's thinking about ML. Like when did you start to think about, okay, we need to build ML models and get them in production? When did you start, kind of building an ML skill set at iRobot?
So I think it's interesting thinking about iRobot's history. When they first started over 30 years ago now, we really almost every single part of the solution had to be made by iRobot, thinking about from the navigation stack to the hardware stack to all the software pieces to how the robot navigates the world and how it uses all that different sensor information. But as the field has changed a lot, and especially as the AI field has changed and deep learning has really transformed, and the quality of solutions that can come from machine learning have really transformed, iRobot's looked at, hey, there's solutions out in the industry that we can leverage, and we can improve our products using those skill sets and expertise. So I think machine learning has been at iRobot for quite a while now. Mainly started in research areas and thinking about how can we use that research, how can we start these research projects and think about how we can improve the quality of our navigation stack, how can we improve the quality of our cleaning solutions, how can we improve the quality of our robotics overall. But just recently, the last few years, it's moved from a research stage to actually being in production solutions, everywhere from improving our digital experiences in the applications to improving our hardware solutions for things like navigation and cleaning experiences. So it's been interesting to see the journey, and I think machine learning is starting to be a bigger piece of the iRobot solutions moving forward.
When do you think it first became like a production thing, and what was like the impetus to what was the application that sort of drove it?
So initially, I think the first application that we could really call ML, if not ML adjacent, really ML, is the SLAM, which is the localization and the mapping of how the robot navigates its space. And that uses a lot of the same methods and a lot of the same now modern tooling. Back then, a lot of the tooling had to be invented by iRobot. And so I think the legacy of ML applications in production at iRobot, if you include the SLAM component, is actually quite long-standing. But in terms of the more typically defined ML, I think it really wasn't something that could have been as important a part of the strategy as it is right now until the robots became connected. So for a very long time, these robots were completely self-sufficient closed systems. They came out of the manufacturing line onto an inventory somewhere into a customer's home. And then it just worked, and there was no way to either collect any information off it or to send information to it to modify behavior. And in late 2015, when we started having the IoT connection component to the stack, that really opened the door to improved data collection, which is really the thing without which you can't have meaningful ML that actually does something that feels automagical to the customer experience. So I think that's sort of from a historic perspective where iRobot started using ML in the production environment. And I think also one thing that shapes the iRobot story quite deeply is exactly what Danielle was saying, is that because a lot of the initial tooling was built in-house, we sort of have had a really interesting blend of standard tool choices versus the deep customization that's sort of really part of the DNA of the company. So that's one of the things that has been really interesting over the last 2 years, especially once this really proved itself internally, and we've been able to demonstrate just how valuable this is, both for our internal use, just to improve our own software development capability, but also to help shape where the strategic roadmap might go, as well as all the other ways in which we can use ML answers to improve the business.
That's so interesting. So it was really internet connectivity that kind of made ML applications possible.
I'm not sure if it's possible, but it's what finally made the case that even if it had been possible before, it might have been prohibitive to collect enough training and validation data for these things to be robust in a way that will work on an apartment in Singapore, the same way that it will work on a ranch in Texas, right? So the ability to really collect the kind of complete picture of what it is that these machine learning algorithms are going to be interacting with, it really didn't make sense because we wouldn't have been able to meet the magical, the light expectation that our global customers might have had.
Cool. And so tell me about your team. So like, what are the different people doing, and like, what are the sort of relative sizes of investment in like the different, like the modeling, the like deployment, like, are you mostly like researchers? Are you mostly engineers? Like, how do you think about that? Like, what are the different functions and how do they all work together?
Yeah, so the team has changed a lot over the years as we've shifted from more of the research side of proving concepts of machine learning applications that we can do to thinking about production applications. So we have a team that's dedicated to thinking about machine learning algorithms and models, thinking about how do we develop those models, what is the appropriate type of data to feed into those models, and how do we improve them over time.
So that team would be essentially like machine learning practitioners. I mean, what is?
Yeah, there's this.
He's an ML mostly, or
yeah. So this is the only part of the team that will be stereotypical ML. So I'll talk a little bit more now about the other parts of the team. So when you talk about a machine learning team, everybody thinks, okay, that's people doing algorithms, right? So we do have some of those people, but it's
like, can you say a little bit about the like relative size of these teams? I think it's just really interesting that you're in production doing this stuff. And
yeah. So the modeling team out of the machine learning team all up is actually a small size. So I'd say they're about a quarter of the size of the full team. So the modeling team, they're doing the algorithm development, and then there's complementary teams that work beside them. So another team that's working is on more of the integration side. So how do they take the algorithms and actually deploy them to the robots? So thinking through what is the supporting infrastructure, the model conversion process to run on this limited hardware. Obviously, we need to not use the same types of models that you can do with big GPU machines. So thinking about the integration of these algorithms onto the robot.
What do you call that team? Is that like ML ops, or?
We actually call this an integration team. Integrating into the robot software and the surrounding infrastructure around it.
And are these people kind of hardware-ish people, or like what's the sort of? Like,
they're still mostly software, but have an understanding of the hardware too, and then they can work with folks in hardware on specific applications.
I see.
Yeah, and one interesting part about doing machine learning applications on robots is it's not just the ML algorithm, but it's how it interacts in the system as a whole. So these are the folks that really need to think through the end-to-end solution of what are the metrics of the system? How does it affect performance of the robot at the end of the day? Things like we want cleaning coverage. We want our robots to clean all parts of their house. We want to maximize these metrics from the customer's point of view, not the algorithm point of view.
So are some of these people like more kind of business focused? Is it?
They're not, but they're thinking about how to capture the metrics to report to the business folks and thinking about what those metrics are. So thinking about the system level metrics rather than just the individual algorithm metrics.
And just to complement that, it's really iterative. So we have sort of an R&D and then a product organization, and there's sort of sister organizations. And so Danielle and I are on the R&D side of the equation, and there are the teams that she's going to continue to talk about. There's the 4 teams within the machine learning proper, and then each one of those has a counterpart within R&D that's attached to a program. So if it's a specific robot or a specific feature or a specific a customer deliverable, there's somebody that's integrating that machine learning component with all of the other R&D components that are necessary to deliver the complete sort of final boxed solution, either as an over-the-air update, an OTA, or either to the manufacturing floor. And then on the third sort of leg to that milk stool is the product team. So we have business counterparts who sort of own that product feature deliverable from the business standpoint. And so they may not know what's technically feasible, or, they're actually incredibly robust at iRobot because we do have a bias for technologists. So that tends to not really truly be the case, but they have these R&D partners who can help them sort of iterate on how do we define these metrics, right? Do we care only about end states and lack of interstitial errors, or do we care about that within the context of cleaning coverage and cleaning efficiency and all of the other, low abandonment rates, all of the holistic experience of what this thing is supposed to deliver? And so that sort of spans the gamut. But for instance, on the first team that Danielle was talking about, the modeling team, the way that they talk to their business counterpart is almost similar to the way that they talk to the integration team. So they can write models and write papers and then tell the integration team, this is the aha, this is the thing, the solution, but they are not as constrained with, what's the compute accounting? How much budget do we have to be able to run this as the robot is doing all of these other things that it actually has to do as well? And so that it truly is a really well integrated and iterative process. It's not sort of they go into their nerd cave, they come up with a solution, and they come out and toss it over the fence.
Yeah, definitely. Good compliment, Angela. So after the integration team, there's a team that's focused on actually what you were mentioning before, Luke, is the platform or an operations team. So that's separate from the integration team. And this is the team that is helping with the infrastructure that supports both modeling and integration work. So things like how do we scale out our compute? How do we train our models and store models and things like that?
So how do you think about the different skill set between that team and the integrations team?
So the integration team is a lot, in our case, because we're deploying on a robot, they also have often C++ knowledge to be able to integrate the models into that environment. They have build system experience around the robot software. So the integration team is more focused on how do we make this stuff real on the robot, versus the platform team is how do we build supporting infrastructure to support both of those other teams.
Gotcha.
And the platform team is generally speaking more cloud focused. And we use AWS at iRobot for a majority of our applications. And so how do we build serverless applications on the cloud to support those different applications?
We found that having an integration team separate from the model and separate from the architecture and separate from sort of advanced solutions is really important, exactly because of this. The last mile of deploying machine learning to production is really long, and we have all of the added complexity that our last mile is on an incredibly restricted, automated, robotic sensor autonomous platform that's deployed in environments we can't control and we can't really modify. So having a team dedicated to focusing on just how hard that last mile is has really paid off in terms of, yes, it's added complexity, having a whole nother team, added specialization. Like that's not free, but it's definitely been net positive.
And what's the last team?
So the last team is a reinforcement learning team. So they're specialized in reinforcement learning applications, and they work closely with the integration team and the platform team for the same applications as the modeling team. Just the modeling team is focused on other applications.
Is that also kind of researchers essentially?
Yeah, researchers and making reinforcement learning real for iRobot.
Huh, interesting. So among those teams, which is the hardest team to hire for?
Oh, that's tough. So oftentimes it's these little gaps in between the teams, and these things that you don't expect you need, and then you find you need in going through a project. And one often overlooked part is aspects around how do we deal with data and how does the data feed the rest of the systems. So even folks who are supporting the team in how do we use the data and how do we curate the data in such a way that our models can improve and our systems can integrate. So often it's the work in between the cracks that you don't, that's the hardest to figure out. Okay, how do we fill these gaps when there's clear work that the teams are working towards?
Where do you think?
One thing that I will note, though, two things I'll note. One, we're hiring.
We are hiring.
So if you have experience in embedded systems and machine learning, tool chain, automation, let me know. We're very much hiring. But also, one thing that's amazing about iRobot is that it's actually not that hard to hire. I mean, yes, it is, because this is a very specialized skill set that we're looking for, given that we've reached a level of scale where that specialization pays off for us. But iRobot is really a really cool place that's really well connected. We got a lot of really smart people working alongside us who have very broad networks. So it's actually, we get a lot of really smart, really competent folks reaching out to us a lot, which I'm very grateful for. Because as you've noted, like these tend to be really hard skill sets to find, but it's also, everybody's 6-year-old gets tickled when they get to answer, what do you do for a living? I built robots.
Totally. That
doesn't suck.
Hi, we'd love to take a moment to tell you guys about Weights and Biases. Weights and Biases is a tool that helps you track and visualize every detail of your machine learning models. We help you debug your machine learning models in real time, collaborate easily, and advance the state-of-the-art in machine learning. You can integrate weights and biases into your models with just a few lines of code. With hyperparameter sweeps, you can find the best set of hyperparameters for your models automatically. You can also track and compare how many GPU resources your models are using. With one line of code, you can visualize model predictions in form of images, videos, audio, plotly charts, molecular data, segmentation maps, and 3D point clouds. You can save everything you need to reproduce your models days, weeks, or even months after training. Finally, with reports, you can make your models come alive. Reports are like blog posts in which your readers can interact with your model metrics and predictions. Reports serve as a centralized repository of metrics, predictions, hyperparameters tried, and accompanying nodes. All of this together gives you a bird's eye view of your machine learning workflow. You can use reports to share your model insights, keep your team on the same page, and collaborate effectively remotely. I'll leave a link in the show notes below to help you get started. And now, let's get back to the episode.
Do you notice that there's any sort of challenges with sort of cultural differences or miscommunications between these teams? I think you actually do kind of hire fairly different people. Has there been any kind of lessons learned from trying to get everyone to work together and build something?
Yeah, so I think one really important thing in thinking about building machine learning teams, and especially when you get to the point where you have different specializations and different goals of these sub teams, is thinking about where the boundaries are between teams and how handover happens. So one way that we've tried to address this at iRobot is we have teams that work virtual teams that work across team boundaries. So for a particular application, there's somebody from the modeling team working on it. There's somebody from the integration team working on it. There's somebody from the platform team working on it. And so they're like a virtual team that works across boundaries. Because I think otherwise there could be some gaps in handover between teams. So trying to build these integration points between the teams is really helpful in getting an end application out the door.
And it's really helpful to also have these teams not feel like there are these arbitrary walls in between them. So the virtual teaming that Danielle described is one way that we do that, but making sure that the folks get a lot of time together discussing scientific papers, getting together and talking about recent developments, attending conferences together, so that there's really this strong culture that allows for a lot of that connective tissue to happen, so that the gaps exist, things do fall through the cracks. There's no way to avoid that, but the fact that we know it will happen, so that we create a culture where folks are attentive to it and intentional in seeking those things out to catch them, rather than going, well, it's not my problem. So I think the fact that Danielle is really intentional about building that kind of cohesiveness, that I'm really intentional about paying attention to that kind of cohesiveness, is one of the things that has been, paying off in spades for us in terms of the speed with which we can get these things to happen and not have to constantly sort of 2 steps forward, 1 step back of, what didn't make it this last time.
Is it a challenge for you to sort of weigh the priorities of kind of what the company needs and the models that the company needs versus paper writing and academic conferences? Has that been an issue for you?
No, imagine. No. I mean, that's been the case for 30 years, right? Like, you hire the best and the brightest, you hire people with a bias towards nerdery. And obviously, all of us want to be big bad nerds. And big bad nerdery doesn't necessarily always pay the bills. So that's why having that iterative component and having a sister organization in the product team that is really well plugged into what the end goal is. Because I think once we reframe how the team talks about it, and we stop the dichotomy of, are we doing cool research or are we doing boring product work? But when we reframe it to, are we solving a real problem, right? Not an abstraction, not a theoretical articulation of a problem, but are we actually seeing in the data that we're collecting back, the telemetry that's aggregated that we can look at, are we seeing qualitative impacts into how humans behave and how they behave with respect to the behavior of their robot? I think getting that and celebrating that and highlighting that, packaging that and communicating that back to the team so that they get jazzed about the fact that what they're doing, that last long mile, once you cross it, you can actually see a meaningful feedback. I think that gets the team really excited to be able to sort of play that game of research and sort of bottom line work in a much lighter way than I had been exposed to previously.
That's cool. So kind of like measuring and communicating.
And having, dashboards across the office where you can see how things are moving, see how the model's converging, both in test, but also whenever it is deployed in production, and seeing the impact on the fleet and communicating that out to everybody else in the company, and hearing all of our partner nerds who nerd on different things celebrate that success. I think it just becomes this really interesting virtuous circle.
Do you think when you interview ML practitioners and those adjacent, do you think that you interview for something a little bit different than other companies, like a Microsoft or a Google? Is it kind of the same stuff, or is there something different about iRobot that you look for?
I mean, I do, but I've never hired for Microsoft or Google. So
sure.
I don't know if I would have had
that example.
if I would have had some pushback, but I was already at iRobot when Danielle joined, so I was really happy to welcome her to the team, but it didn't seem like there were too many sort of fundamental differences with the way the transition happened. Is that right?
Yeah. I can't think of any major major differences.
I think a bias towards a love of hardware helps.
Yeah.
I think if you don't love the fact that these things are going to live outside of your own RAM, it's just not going to be as exciting. And everybody wants to work with somebody who's excited about what they're doing.
Well, that's I think that it does seem like your kind of quality control and testing must be pretty rigorous, right? Because it's probably hard to go back and fix things. Can you say a little bit about how you approach that?
Yeah, definitely. Model quality control and testing is a huge part of what we do. And as much as we can, a lot of these different layers we've automated so that when we're developing software, we have automated tests that run, even automated tests that run on the robot. So we think about it at almost every single layer of the system. So from model algorithm development, thinking about how do we validate our models offline. And even that very first step is tricky, right? Because we're building robots that run in the real world across millions of homes, all the different variety of homes in the world. So even that first part of how do we test our models offline to make sure that they actually will work in the real world, even that is tricky. But after we get over that hurdle, we then think about the next step of deploying on the robot and making sure all those pieces that we need to do. So from the model conversion process to what pre-processing happens to making sure the hardware that goes into the machine learning algorithms is the same as the applications that are developed when we develop the machine learning model. So thinking about all the variety in hardware that goes into the data collection aspects, and then all the where the machine learning model is running, that the software is running correctly. So metrics for offline, metrics for on the robot, and then also once we deploy the model in production, making sure that we continue to monitor that model and continue to understand feedback and improvements so that we can also send updates to the model when necessary. So there's a lot of different layers to that. And it gets really complicated because we're thinking about how do we generalize to the real world and the real homes, and there's a lot of variety in that.
There's a component to testing that goes beyond sort of model quality and model applicability, because these are robots that are in consumers' homes. So we also have a regulatory and a compliance component to the testing. So the Roomba, the Brava, they have a set of testing, but also when you start thinking about things like the Terra, which is the lawnmower, right? That has a completely different kind of fail-stop mechanism because it's got literal blades that are cutting grass, and you definitely don't want it going over Fido. So we have this sort of testing culture and this testing mentality that goes from all the way to how the hardware works, to how the software works, navigation, and then through all of this, the machine learning features that are deployed through these products, be they, recommender systems or computer vision types of applications.
Have there been any interesting surprises, like as you've kind of gone from these like specific unit tests to kind of like more bigger picture tests to production? Have there been any things where you're like, whoo, like we didn't see that coming?
I'd say it is amazing that you continue to find little aspects, and you continue to realize throughout the journey of how important testing is, and not just for finding things, but actually helping you move more efficiently. So having checks at that different layer also just helps you debug faster. So not even knowing, that something is going wrong and being proactive, but knowing, okay, we know something's wrong and we know where something is wrong in the system because we have tests at each layer so that we can really hone into where the problem is. So I think that's something that I've really enjoyed seeing over time, is how building in these different layers helps us move faster in the long run.
So they've all worked perfectly to predict.
Definitely not. So I said we build up tests over time.
But it's really interesting because we've also learned through this process, the sort of navel gazing process of how do we test and how do we ensure and how do we root cause. But we also noticed that across iRobot, our team is also getting called to help those teams root cause what they're going through because of the way that we interact with data. We have brilliant technologists, roboticists, algorithmists, but they are not all sort of trained in the gospel of data and dealing with really large data sets that require imputation, that are gappy, that aren't necessarily fully representative, comprehensive of what it is that a software developer has access to when they're looking at how their IDE is responding to them. So we are able to sort of bring that and help different teams that sometimes have nothing to do with machine learning, but to help them look through the information that our robots are sending back, the telemetry, whatever it be, and then help them build tooling that looks at fleet data to help them towards their specific scenarios, even completely unrelated to machine learning altogether.
How do you think about testing models that are sort of inherently maybe non-deterministic, or at least, you can't be sure that they're going to be accurate every single time? Like, do you have some kind of threshold, or do you look for like distribution drift, or what how do you think about that?
Yeah, this is something that we actually think about a lot, because our systems, we also have data deletion requests that come in, and obviously we comply and think about how do we build in user trust and user privacy into our system. So we think about this a lot because our source data actually changes as a result of data deletion requests. And so thinking about how to build reproducible pipelines that we know what are the components that went into that pipeline, so that we can recreate training data sets based on both the distribution and based on what data went into that model originally, minus the data that was deleted or things that came into the system, and new data that feeds in as well, because we also want to supplement our data sources with any new data so we can improve over time and get better features in the end. So we think a lot about how do we create reproducible pipelines? How do we track what we've done?
Sorry, this is really fascinating. Yeah. Okay, so when you say reproducible pipeline, but the data's changing, what exactly does that mean?
So it means understanding exactly what distribution we're pulling from and what sources we're pulling from, and being able to reproduce the processing that pulls and creates that data set that goes into the model. So
I see. The process is reproducible.
Yes, exactly. Exactly.
But also, whenever we do reach some convergent model, the interpretability and the explainability of that model, while all of the training data is still there as intended and as designed, is really important because of the ephemerality of that data. So if the underlying data, the underlying training set does change, what it ultimately generated, even if we have to change things in order to be respectful and be sensible stewards of our customers' data, we ensure that whenever we do have a model in hand, that the learning of it can be re-implemented in addition to the reproducibility of the pipeline, so that we can't have just blind black boxes that we just retrain at will, because of the regulatory and compliance environment within which we operate.
Yeah. In the reproducible pipelines, we also think about the metrics that come out of those. So some of the metrics we were talking about earlier of the metrics offline, the metrics on the robot. So a lot of those aspects we're working towards full automation so that we can have these reproducible pipelines and reproducible metrics at each layer of the system, so that we know.
Sorry, I'm really interested. So these metrics, when you say these metrics we talked about, you're referring to the sort of like kind of end-to-end sort of product or business metrics, or do you mean something like specific to that model?
So both both. So with model metrics that come out, as well as how that model performs in the bigger system, which there could be a whole other system that it's interacting with on the robot. So you need to think through both the model metrics, and we might need to actually tune the model differently in order to optimize the system metrics. So thinking about those different layers to be able to reproduce. So capturing metrics and then creating those reproducible pipelines are how we think about approaching that problem.
Interesting. And have you seen like modern techniques? I guess like how much has like modeling improvements improved these metrics? Has that been important to you? I mean, some people say, oh, it's just about the data. Some people say, well, no, like, deeper, more sophisticated models, they really matter. Some people think hyperparameter search is a really good idea. In some applications, it seems like it doesn't help very much. Like, where do you stand on those types of things?
So I'd say data first. Data, for our use cases, because we're trying to hit all of the houses, be able to generalize to the world and all the variety of the world, making sure that our data is generalizable in that way and is the most important. But
the physical world,
the physical world.
Yeah. So there are thresholds between, one room and the other.
Yeah.
And the architecture of, 1800s Germany it's something that you really can't modify. Like houses in Berlin will be the way that they are. And so it's really, it's a different world when you're talking about a robot that we're going to be improving these models. We're going to be sending new models over an over-the-air update. But the compute that robot has available to it and the environment within which it operates is static. And so that's the constraint, which is why we value the data collection so much, because of that sort of constraint, essentially.
Yep, absolutely. And the other aspect is the algorithms that run on low compute. I think the advancements that happen in that space, there are little things that you can do that make a big difference. So thinking about that area, I think there is a lot of room to go in terms of how much algorithm improvements can make a difference.
Have they mattered to you over the last couple of years? Like the stuff that's been really meaningful for you?
Yes, especially advances in inference time as well, because we are running in such constrained compute environments. The small differences can make a big deal.
And this is beyond the hardware improvements. This is actual kind of model improvements.
Yep.
Cool. And I mean, well, actually, I'm just this is really specific, but I'm curious, when you think about like hyperparameter search, is that an AutoML, all these things, is that something you do a lot of, or does that help you much? I mean, how do you think about that?
Yeah, we definitely leverage hyperparameter search and AutoML type capabilities to see what the space is out there and see how we can improve. Data augmentation approaches are also very useful, and thinking about how we can supplement the current data that we have to try to make sure that it is generalizable to the world.
Okay, so data augmentation approaches versus model architecture, which do you think is more important?
That's a tough one. Both.
Not obvious. Okay, both. Fair.
I mean, if we had infinite resources, I would agree. But I think looking back at what we've actually had to overcome over the last, call it, year and a half, I'd say that data augmentation has been more of a sort of a throttling or a bottleneck to us. I'm not sure that is always going to be the case, but specifically.
It's been a problem for you, or it's been helpful to you?
It's been helpful. So it solved a thing that was a real problem for us, a bigger problem.
Mm-hmm.
Gotcha.
So the ability to understand every environment from day zero, right? So once a robot starts going around the space, somebody who just bought it, they don't want to give that robot a month to get good, right? They want, if you wait a month, they're going to stop using it, and then you lose the chance of having delighted that customer. So starting off with a really solid day zero solution was really the big important objective for us, I think. But I'm not sure that is always going to be the case, which is why I think both, given infinite resources.
It's early 2020. Things change for sure. I don't know. Can you say, I'm always kind of curious, like when you, like you're like, are you like have you focused on kind of one deep learning framework? Is that like TensorFlow or PyTorch, or do you love scikit? How do you think about that? Is it like all of the above?
So it depends on the team, I think. So when we're talking more about the reinforcement learning team or the modeling team, I think they get a little bit more leeway in experimenting, because that's the role, right? Like, sure. Is the stuff that we've settled on continuing to work for what we want, and will it pave the way for what we are going to want? So those folks test a little bit more, go a little bit more wild into the research and what's available and what are the state-of-the-art sort of improvements, and how can we make those applicable within the environments that we operate in? I think when we're talking about the integration and the infrastructure teams, they're focused on different things. So they are much more focused on that last mile. And so re-architecting all of our tooling, unless there is a really important benefit that we get from that, because at that point you're impacting all of the platforms that may make use of this one deliverable. And a lot of those platforms are already in homes. So if we have to re-architect how all of that delivery happens, there are a lot of teams and there's a lot of integration that needs to take place. And so is it worthwhile to spend those resources? So the farther into the process we get, sort of the harder it is to stay, to modify and to tinker with that stuff. But I think the modeling team, yes, and right, like I think they've done TensorFlow, scikit-learn is always a favorite of all. I think we've dabbled in PyTorch and sort of like figuring out, is it working for us? But once it sort of gets down farther into the pipeline, it is much more into what's already working, and is it worthwhile to sort of, throw a bomb in there.
Can you say what's already working?
Not yet, but we look forward to coming back and sharing a little bit more details on all of that.
Okay, cool. Can't wait. I mean, I want to be respectful of your time. I think we've gone a little over. I'm hoping to end with a couple questions, if you don't mind, that we've been asking everyone. So here's my first one, which is, what is the one underrated aspect of machine learning that you think people should pay more attention to?
Oh, the data. I know it may.
Data
I know it's still, but it's so true. It's so true. The data is so important. Making sure that it's generalizable, making sure that it actually figuring out like your metrics are all going to be based on the data that you're using. And so how do you know the metrics of the model or the metrics of the system are actually metrics that you believe or are useful to represent things? Because it's, at the end of the day, it's all about the data that goes into the system.
And it's not just the volume. I mean, 100% it's the data, but it's not just the volume or the variety or the velocity of it, right? Like the fancy 3Vs, but it's the quality of it. So are we only looking at data that's streaming back from us, from customers who are already happy? Which means we're not solving the problem for the folks who aren't already happy to begin with. We're not solving the problems for the folks who aren't using the product that they've already paid for, and we're not delighting them. So it's not just that we have data, but is that data reflective of the whole? And how do we ensure that the next thing that we do isn't just improving marginally the experience of a fraction of our customers? But yes, data, 100% data, underline.
Why do you think it's so hard for the industry to realize that? Like how could it still be underrated? It's like so it seems so blindingly obvious from where I sit. Like how does
I don't think that it's underrated. I think when you ask this question, you probably get the same answer, which is why we're laughing, right? Like it's not that it's underrated. It's just hard.
Yeah.
Yeah.
It's known to be valuable. It's also known to be really hard.
I know a few companies that will collect high quality data.
No doubt.
All right. So next question. What is the biggest challenge in making machine learning actually work in the real world from where you sit?
So a really tough learning for me was not at iRobot, was at the company that I was at before. And we had this amazing solution. We had this machine learning algorithm that was for energy efficiency, and it predicted sort of when there might be a spike on the utilization of the energy grid or something of that nature. And it worked really well. It was really fantastic. We were all proud of it, and it didn't sell. And so the really important thing is communicating to the right people what is it that they're getting and what the value is, because I think, and I was blinded by this too. I'm not saying that I was smart and I knew it and nobody else did. I wasn't above it, but I was sort of I fell for the mirage of how delightful and wonderful and sexy and how performant and correct it all was. And that doesn't matter. right? Like if it doesn't actually solve a real problem that a real human is willing to part money with in order to have that problem solved for them, it doesn't matter how sophisticated it is, or actually it doesn't matter how much data you have if it's not solving the right problem. Danielle, I don't know if you have a different anecdote or a different experience.
That's a great answer. I would hate to follow that.
Yeah, that was a really good answer.
Notice how it wasn't about iRobot though. Feel free to go to a past life too.
So one of the biggest challenges that I see with machine learning systems in the real world and getting them out there is just there's a lot of different pieces that need to go in to make this right, with the data collection piece, the training part, the processing, the model serving, the software pieces, the hardware pieces, the hardware, in our case, the hardware changes over time. And we also need to make sure the data reflects that hardware changes over time. There's the different homes, the different customers, making sure that it's actually generalizable. So I think there's so many pieces, making sure that you have quality checks in place on those different pieces so that when things don't work as well in general or for a specific customer, we have ways to make it better so that the quality at the end of the day is what the customer is expecting. So I think that's the biggest challenge, is just connecting all those pieces together and making it real.
Cool. Okay, well, final question. If people enjoyed this, and I bet a lot of people are really going to enjoy this, and they want to kind of learn more about your work or reach out to you, is there anything you'd like to link to, or like a Twitter account that you use or anything like that?
Well, first you should definitely go to LinkedIn and you should look at the iRobot page and you should apply to come work with us. That's the number one. The iRobot.com website also, sorry?
Seems like it'd be really fun to work.
It is going to be super fun. And I am not at all biased because I love the people that I work with and I love the work that we do. But that's one place. The iRobot.com website actually has a lot of things for the consumer, but it also goes a little bit into what we do and who we are. So that's useful. Personally for me, you can go to my website. I'm at angelabassa.com. I'm also prolific on Twitter, which is a problem. I'm working on it. And I'm at ANGEBASSA.
Cool.
And I'm on Twitter as well at Danielle Dean.
Awesome. Well, thanks so much. That was super fun. I really enjoyed it.
Yes, thank you.
It's great talking to you.